How's everyone doing today? Awake? I'm sorry, I don't have any swag for you, just knowledge. So we'll see how this goes. Just so I can get a good idea, how many people here are developers? Awesome. How many people work in QA or testing? Okay, cool. How many people work in management or high-level strategy? Okay, cool, awesome. I think we'll have something for everyone here. Let's go ahead and kick this off. And I think we also need to do this. So, welcome. You again. We're going to talk about aligning on schemas for partner APIs in this 20 minutes. So I don't know how many of you have worked with partner APIs before or designed, an API across a partner relationship, but it can get really frustrating and communication can really burn to the ground pretty fast. So it's pretty easy when you're designing an internal API for your team or across teams because you have things like all having similar tooling, all operating within the same email system or Slack system. But once you move out to partner APIs, you run into this issue of collaboration on top of building technology. God forbid, actually moving to the stage of an open API where you don't even have formal structures in order to go and find someone you can work with. So what are the benefits of partner APIs? You have the ability of extending brands. So say I am a company that doesn't have the ability right now to do a mapping service. Partnering with another API can allow me to extend that and offer a lot more functionality. With products and business, it works in a very similar way. And of course, completing product offerings as well. So in a similar way to this mapping, maybe doing something like temperature tracking. Maybe I am a company that provides temperature APIs, but I don't have a way to get it out there, so I partner with this mapping company, and all of a sudden, both of our business is doing a lot better. In addition, one thing that I've previously worked a lot on is deprecating legacy tech. So former partner APIs often become things to be overwritten and removed, as I'm sure some of you are familiar with. So that is another extremely important part of that. And let's just look at a few quick examples of great partner APIs. This is borrowed from a Nordic API article a little bit ago, just taking a look at Tradeshift, Axway, and Pearson. And some of their leadership, just commentary on how they created good partner APIs and what that did for them. So Tradeshift, one thing they talked about was how they took the action when they started building functionality to actually go above and beyond for each individual partner. It can be really tempting to try and abstract things so that no matter what, each partner you bring on is pretty much the exact same functionality, but you do need to sort of do things that don't scale initially before you have fully defined your process. And that starts with the low-hanging fruit. So doing things like exposing your pricing catalogs or your what's in your warehouse right now. Anything that's on an internal system that's really simply accessed is a good target for something that you can surface with a partner API. And Pearson is a really great example of this. They basically surfaced a lot of their pretty simple tech that showed like textbooks and individual assignments that came with them, and a lot of partners came into this ecosystem and built on top of it, and it really changed the entire way that their business functioned and completely blew up their revenue. So looking at the anatomy of this, I mentioned channels, extenders, and completers earlier on. NPR is a really good example of when a partner API program blows up. They launched in 2008, so NPR is the national public radio in America, at OzCon, and they started, I think, with around 60,000 requests happening a month, and within a year they were at 60 million. So what sort of things do they do, and what sort of things do companies in general do? Netflix is a good example of channels. They were a DVD company, right? They were shipping out DVDs until they opened up this digital channel with APIs. that sort of revolutionized their entire system. It allowed them to partner with a completely different channel of company. And extenders, so one thing we talked about earlier was sort of like that mapping API. So allowing you to extend into a different method of business. So maybe going from mapping to temperature. And then completers would sort of be the opposite side of that, where you actually do bring in functionality that you otherwise wouldn't be able to complete and have as part of your project or product. So building APIs together, you oftentimes see a lot of these cool diagrams and best practices, but most people can tell you that these things kind of fall apart as you actually get into the stage of build. And really what it comes down to is it's a people thing. On top of all of this sits communication. And the more people you bring into it, and the more separate entities you bring into it, the more complicated it gets, and less it looks like an extremely simple diagram. So defining those communication standards are really important. And there are a lot of problems that come into this interaction. The first time you make an implementation, you don't know what you're doing. You don't know what your partner program looks like. So you make a lot of mistakes, and you have things like differences in security, compliance, technology stack. So you're maybe using Asana and they're using Jira, and you don't have access to each other's systems. That would be an example of clashing tech, or maybe you are coming from two different countries and both have different legal compliances. We talked earlier about trying to go above and beyond and give extra functionality for each partner, but that does not mean building a new service for each partner. Although you may be extending access to something like your warehouse manifest, you don't want to build a different form of access for each different partner. Don't make a GraphQL and a REST and a SOAP API in order to give access to one resource. Just keep it simple. And then there's this final issue of going public, remaining open. So actually, or going from a partner API to an open API. That's something that shouldn't be considered initially, but it's important to keep in the back of your mind so you can do things like document and set things up to further abstract in the future. Because eventually someone upstairs will decide, hey, this would be really great if we took it further. This is a consideration for management. Oftentimes, communication groups, like you have to think about these sort of 6 things. How do you interact with individual engineers, your team as a whole, the engineers within your same team, different teams, you and your boss and individual engineers. And there's some questions you need to ask them. I'll let you guys read over this pretty quickly. But mostly it involves defining almost a personal schema, something that is like, how do we communicate? How do we resolve problems? What tools are we using? What channels are we using? And it becomes a very complicated process very quickly. And I think there's an alternative to this, as good as managing people problems are. I mean, it is fun. We can replace all of these agreements, all of these people problems with schemas. And why do we want to replace them? Because oftentimes the issue with this communication is that we don't have a single source of truth. Schemas provide that. They give us the ability to abstract our implementation away from if you're working in Java and I'm working in C++, or you're on Azure and I'm on AWS. They completely eliminate this issue of communication and negotiating between those things and reduce it to just a pretty simple document, which allows us to work in tandem and, like I was saying, work quickly across tech stacks, so you don't have to worry about complex conversions. And then you also get the additional bonus of tooling. So you get things like auto-generated documentation, testing, notification tools, things of that sort. A good example of that is, say I am a front-end developer and we're adding a feature that's going to be surfaced to every single team in the company. Normally that would be an extremely complicated effort, but by just defining a really simple, this is a GraphQL type, a really simple schema, we can propose this and backend can adopt it, and then we basically don't need to communicate as long as we're both following it accurately until we're ready to deliver. It's simple, lightweight, and independent. That it has all of these benefits of lacking technology, lacking communication, ties to these things. So let's talk about some common schema formats in the industry. I'm sure you're all familiar with OpenAPI. It's one of the more popular formats. It was Swagger, founded in 2011 as Swagger, and it's really powerful for documentation, right? That's what a lot of people are using it for nowadays. It's maintained by SmartBear, and has the one thing that I can sometimes see as an issue with it is that it has so many different tooling options available, from Swagger Hub to Swagger Hub to Swagger UI to the entire Swagger ecosystem, basically. And then you also have pretty much a bunch of different tools and things that you can do around it. There's different projects involving code generation, test generation, and documentation. So with so much going on in that industry, it's easy to get distracted by different functionality. Of course, I am going to plug Postman here for a second because I work for them. But I actually do fundamentally believe that collections, which is Postman's, I guess, equivalent to a schema format, is an extremely powerful tool. By being an extensible and executable definition, you can take a schema, pull it down directly, and work with it, interact with the API, and see how it works, like actually sort of with your hands when you move forward. In addition to that, you have this entire tool chain that operates around it that lets you do things like documentation and mocking as well. We're not just living in a REST ecosystem, though. It's really nice to think about everything as JSON, but that's not entirely the reality. You have GraphQL, which is this entirely different format for interacting with APIs, and it's really gaining popularity right now. The ability for types to one, they control versioning extremely well, so you can build tooling around them so that you can do things like auto notification, and you don't have to deal with deprecating basically an entire API release when you're moving on to the next one. In addition, it doesn't have any massively popular documentation tools. So that's one thing that you might run into when you set out to use a GraphQL API. API Blueprint is sort of seen as a competitor to OpenAPI and ROML, which we'll talk about in a second. It is not as popular these days. It kind of had a really big blow up in the last few years, and now it's a little less popular. Basically, the differences being that it operates entirely in Markdown. Mainly, it also parses on C++ instead of things like GraphQL, Postman, and ROML or not GraphQL, OpenAPI, Postman, and ROML that parse on JavaScript and Java. The more complex integration for API Blueprint makes it something that I probably wouldn't recommend as much, but that's definitely one of the things that you consider when you go to implement this for your project. In terms of actually, we're a little low on time, so I'll run through this. ROML, pretty similar to the API Blueprint and Swagger. Protobuf is mainly a machine-to-machine communication protocol for basically data streams. It's very popular with Google, but it's very specific and very edge use case. So most implementations won't even really need to consider it. So we'll move forward there. So when building in-build considerations, you do have to consider things like protocol. So like, are you going to be working with HTTP or another protocol? Are you going to, how are you going to be documenting things? Is there a generation tool you're going to be using? In addition, community is an extremely important part that you can't ignore. If you do have multiple developers or hundreds of developers in each partner system that are not being consulted when you sort of release or develop this product, you need some form of outreach and some sort of notification to stay in touch with them. In terms of mocking, I mentioned that earlier, but the one really powerful thing about one of the really powerful things about an API schema is that you can take that defined format and use it to create an example return body. So that gives you the ability to do things like build on these returns without ever having to actually have an operative system. So especially when you have two different partners working together and they haven't yet created functionality, but they both need to rely on each other, schemas really enable mocking. And then management, sort of those higher level concerns that we talked about earlier, that I believe are in some way mitigated when you do start relying on schema a little bit more than relying on these human communication pathways. Once you've set up these APIs, there's some metrics that you should really look at to gauge success on how you're interacting with your partner. Things like usage quotas and at what points you'll have to throttle. Sometimes there is not a very good agreement on the way in which you're going to be using each other's APIs, and you run into some issues in terms of overcalling, overfetching, putting too much load on each other's systems. So looking at those quotas in the first few months of the actual connection and monitoring them is extremely important. In addition to that, doing logging and reporting on those, there are a lot of tools out there, and that would belong in a different talk, but that is something that can't be ignored because you do need to be able to actually look at these metrics. It's also cool to look at over the course of years, how your revenue actually does change, and that's something that you can see by sort of looking at both partners as opposed to just one. And this I will get to in just a second in terms of support and maintenance, but looking at how many tickets are coming in on that specific service, how it will obviously change when you move from an internal to a partner service, but it's extremely important to monitor those and make sure that if they are increasing or if they just in general are just overwhelming, there's probably some consideration design that you need to go back to. So in terms of maintenance, one thing I'll say is I think developer relations is extremely important. In some cases, this might take the shape of partner engineering, but you do need people who are reaching out to and talking to the individuals actually using these APIs. That is one thing that relates back to this community, but you can't really ignore the fact that you need to actively and continually engineer these things, keep track of them. And that is the issue, as we talked about legacy basically deprecation earlier. Oftentimes, you create this partner API, you interact, and eventually the teams move on, you reorg, and this thing stops being maintained. So the aspect of maintenance is extremely important. Versioning concerns are another interesting thing. We mentioned with GraphQL that it doesn't have to deal with versioning as much, which is really one of the superior aspects of it as a format. But in general, you should think about things with Postal's law, which is the robustness principle. So when you go to design something, you want to basically be extremely liberal in what you accept and extremely conservative in what you send, so that as you move forward, you aren't going to, when you make changes, you aren't going to suddenly eliminate someone's ability to to interact with some specific aspect of your service just because you got rid of a single field. And in the same way, you don't want to, just because you got rid of an acceptance field, completely shut down a partner's API. So beyond that, CI/CD and internal testing, just add testing tools to your build pipeline. Actually run these tests and don't just limit yourself to unit tests. Contract testing, in particular, when you're building partner APIs, is extremely important because it lets you, when you establish that contract and know what your partner is relying on you for and what you're relying on them for, running that as part of your build process will really ease a lot of the pain that comes with this the entire aspect of designing a partner API. I could walk through some great partner API programs really quickly and sort of how they changed their companies. If you look at Salesforce, I'm sure everyone's familiar, but the differentiator for them was really launching this the AppExchange program and their partner relations program. They were sort of one of the first people on the scene, and it went from them being a small CRM to them being an entire platform, an entire ecosystem that made a certain percentage on every transaction that happened within that. You look at AWS, which had a completely different focus. They already had the technology to support basically all of the API interactions, but they needed to foster independent learning. So that's an interesting aspect where that technology already being set, they are just going and enriching that community. The eBay is yet wider, that rather than enriching their existing community or generating revenue, they actually onboarded a lot of developers and made it very easy. Created a very low bar to entry in order to actually get on their ecosystem and start building. There are a bunch more examples, definitely something that I would encourage looking into independently. Kin Lane, API Evangelist, has a great article on just sort of looking at different partner programs over the course of time and seeing how they have really changed things. One thing I will call out, which I think is really interesting, is the IRS in basically has the Internal Revenue Service in America has created the first public to private partner API, which is sort of a really interesting thing for politics in general and shows how partner APIs could potentially define the entire governmental process in the future. So in summary, define your process. It gets easier every time. Partner programs are obviously a differentiator for companies. They've driven some of the most powerful companies on the planet to success. When you have these communication standards, leverage them. Turn them into schema. Don't spend so much time being like, talk to this person, talk to this person. Just make a schema. And be aware of the limitations of these formats. So we sort of walked through all that, but they each do have something special about them, and they each are useful in different edge cases. And finally, don't just build it and leave it. Monitor it, maintain it, and have fun with it. Thank you, guys.